You are looking at a 64-square board with 32 pieces. It fits on a kitchen table. A child can learn the rules in an afternoon, and yet this simple game contains more possible variations than there are atoms in the entire observable universe. Not by a little. By a factor so large your brain physically cannot hold it. Let that sink in. A board game designed over 1,000 years ago is more complex than the fabric of reality itself. Here is the number, 1 followed by 120 zeros. That is how many possible games of chess exist. Mathematicians call it the Shannon number, and when you try to picture it, your imagination simply gives up. Now compare it to the estimated number of atoms in the observable universe. That number is roughly 1 followed by 80 zeros, meaning chess does not just have more games than atoms. It has 10,000 trillion times more. You could assign a unique chess game to every single atom in every star, every planet, every grain of dust floating in the void of space, and you would still have almost all the games left over. This was first calculated in 1950 by a man named Claude Shannon. He was a mathematician at Bell Labs, and he published a short paper called Programming a Computer for Playing Chess. It was only 14 pages long, but it changed everything. Shannon was not trying to play chess. He was trying to understand what it would take for a machine to think. And in doing so, he accidentally revealed that the game sitting on your shelf is one of the most complex objects humans have ever encountered. So how did he arrive at that number? Shannon looked at a typical chess game and estimated that at any given moment, a player has roughly 30 legal moves to choose from. After each pair of moves, 1 white and 1 black, that means about 900 possible positions. A typical game lasts around 40 moves per side, or 80 half moves total. Multiply 30 by itself 80 times, and you get a number so enormous it barely fits on paper. 10 to the power of 120. That is the Shannon number. Now here is what makes this so staggering. The atoms in your body, the air you are breathing, the screen you are looking at right now, every grain of sand on every beach, every drop of water in every ocean, every particle of dust in every galaxy, all of it combined adds up to roughly 10 to the 80. Chess has 10 to the 120. The gap between those two numbers is not something you can bridge with effort or time. It is a gap that exists in a dimension your brain was never built to process. Try this. Imagine you could somehow list every atom in the universe, and imagine each atom got its own personal universe, just as full of atoms as ours. You would now have 10 to the 80 times 10 to the 80 atoms, which is 10 to the 160. You are still nowhere near the number of chess games. To reach 10 to the 120, you need 10 to the 80 multiplied by itself 1.5 times. The universe is simply too small. In 1997, IBM built a computer called Deep Blue, and it beat the world chess champion Garry Kasparov. It was a historic moment. The machine evaluated 200 million positions per second, and it won. But even at that speed, Deep Blue could only ever scratch the surface of what chess contains. It could not calculate every possible game, not even close, not by an incomprehensible margin. If every atom in the universe were a computer as fast as Deep Blue, and they all ran for the entire age of the universe, they would still only explore a vanishingly tiny fraction of all possible chess games. 20 years later, in 2017, a team at DeepMind built an AI called AlphaZero. It did something even more remarkable. It taught itself chess from scratch. No human strategies, no opening books, no database of past games, just the rules and 4 hours of playing against itself. In that short time, it developed a style of play so creative and so devastating that it crushed the strongest chess engine in the world, Stockfish. AlphaZero did not try to calculate every possibility. It could not. No computer ever will. Instead, it learned to feel its way through the infinite landscape of the game, guided by something that looked suspiciously like intuition. Victor Alice, a Dutch computer scientist, calculated in 1994 that the game of Go has even more possible positions than chess, roughly 10 to the power of 170. But even Go is finite. Both games are dwarfed by numbers that describe the real physical world in ways we rarely stop to consider. And yet chess, with its modest board and familiar wooden pieces, remains one of the clearest windows into the true nature of complexity. Here is what is truly unsettling. You have probably played chess. Maybe dozens of times, maybe hundreds. Every single game you have ever played, and every single game anyone in history has ever played, accounts for such a tiny sliver of what is possible that it is essentially zero. The games humans have explored are like a single grain of sand compared to all the beaches on all the planets that could ever exist. Every brilliant combination, every famous checkmate, every grandmaster masterpiece, they are all drawn from an impossibly narrow slice of an ocean that has no bottom and no shore. This is not just a curiosity about board games. It is a window into something fundamental about the universe you live in. Your brain is a pattern-matching machine. It evolved to deal with things it can count on its fingers, things it can picture in its mind, things that fit inside the scale of a village or a forest or a sky. 10 to the 120 is not a number your brain can picture. It is not a number at all in any intuitive sense. It is a doorway into a kind of complexity that exists everywhere, hiding inside systems that look deceptively simple from the outside. A strand of your DNA contains roughly 3 billion base pairs. The number of possible genetic combinations in a single human is estimated at over 10 to the power of 6,000. The number of possible protein configurations is even larger. The possible neural connections in your brain, the possible arrangements of molecules in a glass of water, the possible configurations of matter in the visible universe. All of these numbers make the Shannon number look small. Your everyday life runs on a foundation of staggering mathematical complexity that you never see. When you shuffle a deck of 52 cards, the number of possible orderings is roughly 8 times 10 to the 67. That number is so large that almost certainly no deck of cards has ever been shuffled into the same order twice in the entire history of playing cards. Every time you shuffle, you are holding something that has never existed before and will never exist again. And yet that number, impressive as it is nothing compared to chess. The next time you see a chessboard sitting quietly on a table, remember what you now know. That board is not a simple game. It is a map of a landscape so vast that no human, no computer, no civilization that will ever exist could explore more than a whisper of it. Every piece on that board is a doorway. Every move opens a corridor that branches into corridors that branch into corridors, stretching out beyond the horizon of everything that exists. Claude Shannon saw this in 1950, and he wrote it down on 14 pages. He gave the world a number. And that number, 10 to the 120, is still sitting there, quietly reminding us that the universe we live in is far stranger, far deeper, and far more infinite than the human mind was built to understand. The board is 64 squares. The possibilities are everything that could ever be. And the gap between those two things is where the real game begins.